And then it'd be 14.
Okay, let me take roll. Okay. Steve, Ian, Eric, Anne is here. Camacho is here. Kramer, Chinsky, Lopez, Barbara, Lopez, Brenda, Malmberg, Martin, here. Reed, Retzlaff is here. Richie is here. And Yakushenko here. All right, so for chapter 4, the chapter was if you watch the videos, it would be, oh yes, ma'am.
Did you say read? Did you say read?
Yeah.
Oh.
I did say read. I remember seeing that name. And you are the other Lopez.
Yeah. Yeah.
All right, so as I was saying, chapter 4 is relatively short. I would say the main thrust of chapter 4 is dealing with the nature of elements in terms of the composition of the atoms. So basically, that's what we'll be focusing on, especially when it comes to the assignment. So let me just briefly recap what was talked about. Elements. So elements are substances that cannot be broken down into anything simpler. And basically, if you have a sample of an element, if you look at what happens at the microscopic level, you'll see that they have the same type of atom. Right? So elements are substances that cannot be broken down into anything simple. Simpler substances by chemical means. So, as you can see on the periodic table over there, it's a comprehensive list of different elements. And you'll see that there are two numbers associated with each element. One number is called the atomic number, which we're going to talk about shortly. And the other number, the higher number for each element is called the atomic mass, right? So before we get to those terminology, I want to talk about the composition of the atom, right? Of each element. So each element has its own unique atom, which has a particular composition, right? And there are three main particles that are present within any atom or most atoms. You're going to have the protons, which are positively charged. You're going to have the neutrons, which, as the name suggests, are neutral, so no charge. So here, and then you have the electrons, right? And the electrons are negatively charged, right? And for each atom, the number of protons is equal to the number of neutrons. Right? That's true for, I'm sorry, number of electrons. Right? Number of protons will be equal to the number of electrons. That's true for every single atom. Now, as far as the number of neutrons are concerned, they don't have to be necessarily equal to the number of protons or electrons, right? They can be, but they can also be, usually higher in terms of number, right? Another term, oh, and by the way, in terms of where the different particles are located, the protons and neutrons, that I know here, protons and neutrons are located in what is called the nucleus, which is at the center of the atom. It's located in the nucleus. And the electrons are outside the nucleus, surrounding the nucleus. Outside the nucleus, all right? So that's where these different particles are located, okay? So now we get to the definitions of the numbers that I mentioned earlier. So each element has its own unique atomic number, all right? So the atomic number is equal to the number of protons in the nucleus of an atom. Nucleus of an atom. All right, so each element has its own unique atomic number. So you can use the atomic number to identify the element. So for example, if I were to choose an arbitrary example like silver, silver, as you can see here, has an atomic number of 47. So that tells you that there are 47 protons in the nucleus of the atom, right? And because the number of protons is equal to the number of electrons, we can conclude also that the number of electrons in the silver atom is also 47, right? Now, the other number, which is not indicated in that table, that you need to know about is called the mass number, right? And the mass number by definition is the sum of the number of protons and neutrons in the nucleus of the atom. All right? Now, that number is not indicated in that table, right? And a lot of students, when they meet this for the first time, they think that the bottom number or the higher number is the mass number. That is not the mass number. That is a different number. It's known as the atomic mass, right? And students tend to confuse those two, but they're two different things. Even though numerically they're close to each other, but by definition, they're two different things, right? So please do not make the mistake that the higher number for each element in the periodic table is the mass number. The mass number can only be determined by what you see there. It's the sum of the number of protons and neutrons in the nucleus of an atom. Now, the reason why that is important is because you can have two atoms of the same element, which means that they have the same atomic number, but they have different mass numbers, right? And there's a name for those particular types of atoms. These are called isotopes, right? So isotopes are atoms having the same atomic number, but different mass numbers, right? And the reason why they have different mass numbers is because they have different number of neutrons, right? So a good example of this would be, and by the way, before I even go into the example, there is a representation which takes into account the atomic number mass number and the symbol of elements. We call it an isotopic symbol. So let me introduce that to you first, and then we talk about specific examples. So an isotopic symbol is a shorthand way of representing a particular atom in terms of the atomic number, mass number, and the symbol of the element. So typically, this is what it looks like. You have the symbol for the element. I'm going to use E for representing the symbol of the element. And A here represents the mass number, and Z represents the atomic number. So A is equal to the mass number, and Z represents the atomic number. Right? So if I write this down, 12, 6, C, right? Then based on just that information alone, you can tell a couple of things. You can tell, well, it's carbon because the formula is C. You can tell the number of protons because of the 6 down here, which is the atomic number. And the 12 here is the mass number, which is the sum of protons and neutrons, right? So based on this, you can tell the number of protons, you can tell the number of electrons, and you can tell the number of neutrons, right? So that's an example of an isotopic symbol. Another example would be this. All right, again, 11 would be the atomic number in this case, 22 would be the mass number in that case, and so on and so forth. Na is the symbol for the sodium and so on, right? So whenever you see something looking like this, then you should be able to interpret it and come to some conclusion as to the nature or the number of particles present in the atom represented, right? Now, with that said, let me talk about isotopes. So, as I said before, isotopes, I gave the definition here. These are atoms having the same atomic number but different mass numbers, right? So, an example of two isotopes would be carbon 12 and carbon 13, right? Same element, carbon, right? So what that means basically is that they will behave similarly in terms of reactions and so on. They have the same atomic number because they're the same element, but the difference here is the mass numbers, right? So if we were to look at the number of electrons in each case, this would have 6 electrons, this would have 6 electrons. If you look at the number of protons, in each case, this would have 6 protons, that would have 6 protons. But if you look at the number of neutrons, right? How do we get the number of neutrons? Well, we find the difference between the mass number and the atomic number in each case, right? So in this case, 12 minus 6 gives you 6. But in this case, 13 minus 6 gives you what? 7, right? So because the number of neutrons are different for the isotopes, that means that the mass number will be different. And that's what makes them isotopes. Isotopes are atoms having the same atomic number, but different mass numbers, right? Same atomic number, which means that they have the same number of electrons, same number of protons. But the mass numbers are different because the numbers of neutrons are different. Okay, let me give another example. Suppose you're given 3517 Cl and 3717 Cl. Again, these are two isotopes of chlorine. So what would be the number of electrons in each case? What would be the number of electrons in each case? Remember the definition, remember what I said here. Z is the atomic number, which is here. And A is the mass number, which would be the superscript here. So if you translate that to what we have here, 17 would be the atomic number, right? And therefore the number of protons would be, sorry, the number of protons, number of electrons would be 17. The number of protons would be 17. And what would be the number of neutrons? Hmm? 80. What about over here? In case of chlorine 37, the number of electrons will be what? 17. The number of protons will be 17. And the number of neutrons will be 20. Exactly. So that's basically how you can determine the number of particles based on the formula, right? So what I'm going to give you now is basically an exercise in showing that you know the relationship between atomic number, mass number, number of protons, number of neutrons, number of electrons, and the symbols as well, all right? So let me give you guys this now. And I'll be collecting this at the end of class. For you. For you. And for you guys out there in Zoom. I don't remember if I published it, but if I haven't, let me do that now. Okay, so let me do this. Okay, so for you guys out there in Zoom, it is now published, so you can download it and get started on it. And of course, I'm here if you have any questions. So let me just give you a little help with the first one. Let me open this up here. Okay, so I'll probably help you with the first couple of these. So for the first one here, we're starting off with copper. Turn this on. Okay, so for the first one, we're starting with copper. So what's the symbol? The symbol is Cu, right? So the atomic number, how do we get the atomic number? We consult the periodic table, and according to the periodic table, the atomic number is 29, right? Now, this is asking for the mass number. The only way you can determine the mass number is by adding the number of protons to the number of neutrons, right? So here we have the number of protons, here we have the number of neutrons. So that's 29 plus 35, that would be 9 plus 5, 14. Is that what, 64? Yeah, so 64 would go here. And that's it, right? We have basically completed the first line, all right? Okay, what about the next one? Tin. Okay, so they gave you the formula and the name, the atomic number. What's the atomic number of tin? 50. 50, right? And how do we get the mass number? Right? Yes, sir. Okay, well, the atomic number would be the number of protons, right? So let's put that here, 50, right? So how do we get the mass number? Protons plus neutrons, so that's 50 plus 69, which is what? Is that 119? Yeah. That's it, right? So if you understood what we just did, you should be able to do the rest of it, right? Meantime, let me see who came in late. Okay, there's Ian here. I don't see him. Billick. Billick here. Oh, Billick is here. Kramer is here. Karachinsky. Let's see. That person. Okay. I think that's it. You can't answer, but before you leave, let me just say that, let me remind you guys about your test next week. You have to go to the testing center to do it. And, when you get the test, please look for spring 2025 at the top, right? To start doing that now so that they give you the right test, okay? There's something else, I want to mention, and that is that. Oh, so make sure you watch the videos for chapter 5. I've just published them. All right. And also remember the event tomorrow. If you can make it, you can join by Zoom, the event dealing with career, STEM careers. It's going to start at 12:30. Should finish within an hour, maybe an hour and a half. All right, so if you're interested in STEM careers, you can join and be informed. All right, I think that's all I have by way of announcements. Yes, sir.
Homework for this chapter.
I'm sorry?
Like, is this the homework for this?
Yeah, that's it. Yeah, that's what I'm going to grade for in this chapter. Oh, I just remember. So, I just realized, while I was sitting here, that, well, you guys should have received the graded assignment number 2, right? But there's also assignment number 3, which I forgot to send to you guys, so look out for that. I'm gonna send that to you because your test will be based on those 3 chapters, chapters 1, 2, and 3, right? So in preparation for your test, I would suggest that you review those assignments. I think I posted the assignment keys. If not, I'll do that. Review the assignment keys. Review also some past tests. I think I've, yes. Okay, so I have posted some past test number 1 as well. So you may want to review that, as well as, you may want to try some questions from your textbook. So if you do all of that, you should be in good shape for your test, right? So make sure you make the appointment for the test. You go online and make your appointment. Make sure you bring a pen and a calculator. That's all you're gonna need because everything else will be provided for you, all right? And I think that's it. All right? You change your name in Canvas, if I'm not mistaken. Okay. Let me see here. Hold on. Barbara Lopez. That's you, right? No, was you.
Yeah.
You haven't changed, I thought I saw it changing, maybe.
I changed it in Canvas, but it only shows like that on the emails.
Oh, okay. When did they get to it?
Have a good one.
Yeah, you should take care. You guys out there in Zoom, are you okay? Um. I'm going to, provide a Dropbox for your assignments. So you can submit it. I'm gonna put the deadline date as, tomorrow, because this is a fairly simple exercise, so let me do that now. Before I forget. Okay, so I've just created a Dropbox. So you guys can, submit your assignment. Assignment number 4 there. The deadline date is tomorrow, right? So make sure you do that. I'm gonna sign off now because there's nobody here in class, so if you need any help with this assignment, feel free to contact me, all right? I have office hours, let me see, I have office hours tomorrow from 2 to 6, all right? Okay,